All right, section 13-1, we're going to take a look at a little bit of calculus before the end of this course. The idea is that when you step into calculus, you'll kind of be a tiny bit ahead and it won't be all new. So one of the concepts that we talk about at the very beginning of calculus is the concept of a limit. And the way I'd like to define a limit in real layman's terms is the limit of a function is the y value that occurs on the left and the right of an x value. I could also say, instead of left and right, I could say near an x value. Okay, so the idea is this. If I pick an x value, let's say on this picture we pick the x value of 4. The question, when I look directly at 4 and ask you what is the function value, you would say, oh, well, at 4, there's a hole up here. The function's actually defined here and at -2. So in this situation, I would say that f of 4 equals -2. You did that in algebra 2. But when I ask you what's the limit of 4, what I'm asking is, what's happening right next to 4? So not directly at it, but just to the left and just to the right of 4. Well, if I'm just to the left of 4, I don't track down to that dot anymore. I actually now at 3.9 or whatever, really close, I track up here. And just to the left of 4, I'm very, very close to 8. Not exactly 8, but very close. And if I'm just to the right of 4, the same thing happens. I track up and I'm very, very close to 8 again. So what I would say is the limit of the function at 4 is 8. So the difference is the limit is right on either side of the value, and the function, the f of 4, is right at the value. And the notation for this is we say lim, so that's a script L, and then below that we tell what x value we want to look at. We say x is going towards 4. The arrow is there because the idea is we're not at 4, we're getting close to 4. The limit as x goes to 4 of the function, drawn here, if we call this f of x, equals 8. Okay? And that's the idea. Now, let's look at another place on this function. Let's consider, let's say 1, or -1. Okay, so let's first look at what is the function at -1. So that means I'm going to take -1, go straight up to the function, okay, and straight over to my y value. So this is going to be 3. Now let's take a look at the limit as x goes to -1. Well, that means it just a little on the left and a little on the right. Well, look, they're still pretty close to 3. So this is also 3. So the limit is not necessarily different than the value at the point. It can be, but it doesn't have to be. But the idea, every time I say limit, you're going to look a little to the left and a little to the right. Okay, let's try another x value. Let's try x equals -2. Let's look at this place. So first let's figure out what is the function at -2. So I go up and down from -2, and where do I hit the function? I hit the function right here. That's where my closed dot is. So the function at -2 is 3. Now let's look at the limit. If I look a little to the left of -2, I actually have to trace down to hit the graph, because if I'm tracing up, I miss the graph. See that? It doesn't hit the graph anywhere. So you have to go down. And I'm very close to -1 on the left. When I go to the right of -2, I can't trace down anymore because I missed the graph. I actually have to trace up. I missed that dot, and I have to go all the way up here to get a value, and I get 6. So in this case, on the left, I'm getting a different number than on the right. So what does that mean? Well, that means that the limit as x goes to -2 of the function does not exist. We use DNE. Okay, so let me write something down here in the way of kind of a plan or definition. Let's do it in white. To calculate a limit, the left side has to match the right side. Okay? If they don't match, the limit does not exist. Okay? So in this situation at -2, the limit doesn't exist, but it's kind of disappointing just to leave it at that because I did come up with some numbers. So is there a way we can talk about what's happening there? And the answer is yes. What we do is we talk about the limit as x goes to -2 from the left. Now that's a little tiny minus sign up in the power position of that -2. What that means is this is the limit as x goes to -2 from the left. Negative is left. So this actually does exist. If I just look at the left-hand side, that's what we did right here. And that value is -1. Okay, similarly, I can say the limit, here, let me drop down here a little bit. I can say the limit, LIM, as x goes to -2 from the right. That's a little power, a little plus sign in the power. That, well, we did that earlier as well. If I'm just to the right of -2, I'm coming up here to this 6 value. So I would say the limit as x goes to -2 from the right is 6. So I can talk about what we call like left or right-handed limits or sided limits, okay? From the right-hand side and from the left-hand side. It's just not defined overall from both sides. Okay, so here's kind of the formal, more of a formal definition of the limit. The limit as x goes to a number, okay, we'll call that a, exists if the limit as x goes to a from the left equals the limit as x goes to a from the right. Okay, so that's a little bit more of a mathy formal definition. And what all we're saying is if you look at the left side, like we did here, if you look at the left side and you look at the right side and they're both going to the same place, then the limit exists. But as we did over here at -2, if the left side's going somewhere and the right side is going somewhere else, then the limit doesn't exist. So what you're going to be doing in your homework is you're going to be looking at graphs like this, and I'll be asking like, hey, what is the value of the function at these points, as well as where's the left-hand limit, right-hand limit, and overall limit going. Okay, so let's try one more and see, just kind of solidify that in. Let's look at the value of 2 right here. First of all, the function at 2, well, I trace up and down till I hit the graph. Oh, well, I'm already on the graph right here. So the y value, and this is also important. Notice I said this is the y value. All the limits and all of these guys are always going to be y values as your answer. So keep that straight. F of 2 is going to equal 0. That's my y value of 0. But as I look, let's look at the limit as x goes to 2 from the left. So we're going to take a look at just this left side. I have to trace either up or down to hit the graph. Looks like I'm going to have to go up to hit the graph. And I'm going to be very close to 6, right? As close as I want to 6. Because if I'm not close enough to 6, I just get closer to 2. And then that comes closer into 6. That's the idea. It's like I can get close enough to 2 to get as close as you want me to 6. So I would say the limit as x goes to 2 from the left is 6. Now let's look from the right. So limit as x goes to 2 from the right. Well, here's the right of 2. I'm going to go, I'm just going to go here. I just stop right there. I hit the graph. I'm pretty close to about, looks like about 1. Okay, so because the limit from the left does not equal the limit from the right, what that means is the limit as x goes to 2 overall does not exist. All right, so be aware if there's little signs up here in the powers, that means just a left-sided limit or a right-sided limit. And then if there's no sign up here, that means overall matching the left and the right. This is a new concept for most of you, and it can be a little weird. So embrace the weird and do some problems. This will get a little bit more natural as we go on. Good luck.